everyone. Today I will try to describe how we are integrating MATLAB in our Energy Systems Department studies. First of all, in our Faculty of Engineering and Natural Sciences, in Energy Systems Engineering Department, we are using MATLAB in different courses, but fundamentally in Experimental Design in Energy Systems lecture, for fourth-year students, they are using MATLAB in their projects. They are designing 4 different projects during one semester, and they are trying to use realistic constraints and requirements of the real systems, solar energy systems, wind energy systems, and they are trying to identify, formulate, and solve their problems to give the efficient results in their studies. And the most important advantage of the MATLAB for our studies is easy to adapt and configure for different energy sources, solar panels, wind turbines, batteries, or fuel cells integrations are easily configured in our simulations. For MATLAB, in our lectures mainly, we are using Simulink toolboxes, but mostly SimPower systems elements we are using, and in addition to this, renewable energy tools, which I said solar panels, batteries, wind turbines, and fuel cells are the main components of our projects. This is the first project of the experimental design in energy systems. The students are trying to obtain the mathematical model of a solar panel. They are not using the ready panel model of the MATLAB. They are bringing together some math tools, and they are creating the equations of the solar panel. And finally, they are designing their own solar panel, because the important point for our projects, they are selecting their own products in their projects. So based on their specifications, they use as an input their datasheet values, and finally they are creating a similar result with a solar panel, but they can be more familiar with the math details of the Simulink tools. After that, for example, this is the second project. For the wind turbine system, they are using ready example of the MATLAB initially, but they are trying to change some components of this system, because this is a defined power rating wind turbine system, but each group in our classes has different power ratings, different requirements. So based on their requirements and desired needs, they are changing the components in this example, and they're creating their own system based on the realistic constraints. And they are testing their systems based on different operating conditions, so they can see also visually the outputs of wind turbine system. And in parallel with this one, solar and wind energy projects, they are doing the laboratory studies, experimental studies in our laboratories. So they can compare the results of simulation, their calculations, and the experiment studies in a same time. This is the third project of experimental design study. They are using the fuel cell stack of the MATLAB. They are using the ready block of the fuel cell. And again, our aim to use the real data of a real system, real fuel cell, real panel, to enter to the tool of the MATLAB, and to compare the simulation results with the real results. On the upper side, you can see the simulation results of the study, and the below side, it's real output. They are trying to understand the differences between them because of the operating conditions, or based on their inputs in the system. And this is another lecture, actually, modeling and analysis of dynamic systems. By using different features, we are trying to understand the MATLAB and the real system differences. First of all, I'm explaining handwritten solutions for a simple systems. It can be mechanical system or electrical system or thermal system, different systems we are examining. So first of all, we are solving mathematically in our lecture. Then we are modeling by using the same components, same configurations on MATLAB tools. Then it's state space representation. You can see again, state space analysis can be obtained, or block diagram representation can be analyzed by using the MATLAB tools. So by comparing the results, we can compare our studies in MATLAB with different representation or solving methods. So how we are using the MATLAB actually in class or out of class applications we are using in class. First of all, last example modeling lecture, we are giving the differences of handwritten solutions and the simulation results. Sometimes for the handwritten solutions, we cannot reach to the end of the calculations because of the complexity, but by using the MATLAB with 2 lines codes, we can see, I can show the results to the students, and it can be very clear example. So for out of classes, they are preparing different projects in different lectures. In addition to this, we are giving some homeworks, especially the laboratory studies. They are designing their experiments, our electric machinery lecture experiments on MATLAB also. We have some machines, induction, synchronous, and DC machines, and their load performances we are examining in the laboratory. Before the laboratory experiment, they are creating their systems on the simulation. So when you when they come to the laboratory, they can compare their simulation and experiment results also. So they can get great experience by using the MATLAB and Simulink, especially in energy system applications, because it's very hard to create such a system in laboratory situations. But on a simulation platform, they can easily configure different type of systems. And also we can compare theory and simulation in different lectures and studies, and especially in energy systems experimental design lecture, we are trying to give project-based learning to students based on their project results. We are evaluating them. This is another study actually. Shortly I can explain. This is my rectifier, AC to DC converter, and MATLAB integration. It's hardware in the loop integration. I'm using the Texas Launchpad and to write the detailed codes, control codes of the Launchpad to control the rectifier. I use the MATLAB, and it helps me actually to shorten the time. And as an online tools, in addition to our project studies, simulation studies, I'm giving some tasks to students as self-paced courses. MATLAB on-ramp, Simulink and on-ramp, Simulink fundamentals, SimScape on-ramp, power electronics simulation on-ramp tools. They are following these courses, and they are taking their certificates to get some points from the lectures. Okay, thank you. Thank you for your listening. That's all for my presentation.